there was a bit of a mix here, so we'll start with two. We'll start with two, okay? So the fishing on a particular lake is weather dependent. A fisherman finds that if it's cloudy, then there's a 75% chance of hooking a fish. And when it's sunny, there's a 50% chance of hooking a fish. You can tell how the cloudy, whether or not it's cloudy, affects my outcome for hooking a fish. So definitely dependent. Over time, he is fishing. Over the time he's fishing, it's predicted to be cloudy 60% of the time. So I would start my tree diagram with maybe cloudy, not cloudy, right? And it's going to be cloudy 60% of the time. And it's going to be not cloudy, which is really sunny, 40% of the time for that reason. And then the options would be catching a fish. I guess we can say hooking a fish, not hooking a fish. It doesn't matter. Whatever you used is fine. Those are my two branches that go off of each one of the first ones, right? So when it's cloudy, there is a 75% chance of hooking a fish and therefore a 25% chance of not hooking a fish. When it's not cloudy, i.e. sunny, there's a 50% chance and therefore 50% chance. So it doesn't matter if you have it in a different order. Like if you put this here, like if you went cloudy, not cloudy, if you flip that, as long as your branches line up with what I have, like 0.6 lines up with these two numbers and 0.4 lines up with these two, you're fine. I will give you a mark already for this. If you have this, you got the mark. But I want all the outcomes, right? So probability of cloudy and hooking a fish, probability of cloudy and not hooking a fish, not cloudy and hooking a fish, probability of both of them not being the case, right? So let's see, when you multiply these two, you get 0.45. No. Yes, 0.45, okay. 0.15, 0.2, and this is 0.2 as well. Yeah. And I know this is 0.6 and another 0.4. This is going to add up to 1. So I'll give you another mark for having those numbers there. Okay. So in fact, if we go back up to the 3 marks, we're going to cross that out, and that's usually just worth 2 marks for the province. To have done this is 2 marks. So this is A, right? I've gotten 2 marks for A. Now B, what's the probability of just hooking a fish? It's basically asking for this. And you've got 2 options. So again, we multiply when we go down the branches to come up, because it's and, this happening and that happening. Hooking a fish, you've got 2 options, right? You've got 0.45 and 0.2. So that's 0.65. Okay, so that's what you've got there, 65%. C, it's asking for this, probability that it was cloudy given that a fish was caught. And so what do we do at the top? Probability of cloudy and fish, right? That goes on top because it's these 2 letters there. And what will go down here? F, right? Oh. Why do I go to F all of a sudden? C and H, right? My bad. Almost looks like an F. I mean, come on. See, right there. Right there. Totally. See, that's why I put that poster up there. No one is perfect. That's why pencils have erasers. Remember that. So this is 0.45 divided by hooking a fish. Coincidentally, I already have that. So you just divide those 2. And you get 0.6923 or 69.23%. I'll give you 1 mark for each. 1 mark for the 0.65, 1 mark if you got the 0.6923 figured out. Okay? So this question is worth 1, 2, 3, 4 marks. So just for question 2 is worth 4. And then we're going to go to 1 now. I said one of them is a tree diagram. You're like, tree diagram everywhere. But that's okay. We're learning. When going to Duke of Edinburgh hiking trip, there's a probability of 0.77, right? That probability to get a wood tick. Nasty, right? What's the probability? It's 89% of a student getting blisters. The probability that a student gets neither is 0.04. What does that sound like, neither? Doesn't it sound like outliers to you? I was hoping. Even if they had said of getting both is a certain percentage, that is like joint sets, Venn diagram, okay? So in this case, it's going to be a tick is 89%. Are there overlaps, you think? We don't know yet, but let's figure it out. This is blisters, 89%. 77%, 89%. In case you're watching this and don't know what I just did, I pointed to my poster. Okay. This is 4% here. Determine the probability that a student gets both blisters and a wood tick. That is going to be the overlap. That's going to be the overlap. So I'll say this, if you got this far, you get a mark already. If you kind of got it going, you realize it's Venn diagram, that's good. What do we need next, guys, to get this going? We need the intersection, right? There's no other way. Venn diagram, you need your intersection, then we move out. So that's called, we use pi, right? I'm going to call that x. So really, it's 100, right? The union of these sets, it's 100 minus outliers. And then I add up the set that has wood ticks and the students that belong to the blisters. And we go subtract the overlap. So this is going to be 96. And this gives us 166 minus x. I take away 166. You end up with negative 70, like that. And we know that x is equal to 70%, right? Can that be? If this is 70, will that work out? Absolutely. This is 7, and this is 19. Like, you don't get any negatives, right, in the Venn diagram, so we're good. By the way, if you just circled this, and if you were able to do all of this without a Venn diagram, you get the marks, okay? But I need a Venn diagram. I just can't do it otherwise, okay? So one for the, you don't have to have it filled in, to be honest. If you have the 70, you get 2 out of 2. No matter what else you did, you get 2 marks for that. So 2 and 4, that's out of 6, correct? 6 total. So put that down. And once you've added it up, please